All right, guys, so here's where things get really, really super fun. So let's kind of recap back to the product rule and the quotient rule stuff. If you remember, I had you try to keep everything organized while you're doing the product rule and the quotient rule. Like in the product rule, I had you write down what function is u, what function is v, what is u prime, what is v prime. And then for the quotient rule, what's high, what's low, what's d high, what's d low. And I told you, even though at the time you were probably thinking like, oh, these are simple equations, I don't need to write all this stuff down. I've been telling you that, hey, things are going to get a lot more complicated. Let's get in this habit now. And so that way we can keep ourselves organized. We know where everything is. This is that time. This is the time where everything is going to get very complicated. So example 8, this is a chain rule inside of a product rule. So if you look at this equation, y equals the sine of x squared times the cosine of x squared, we are looking at not only a product rule, because we need to multiply these two equations together, we're also looking at a chain rule, because inside of each function, there's a nested function. There's a nested x squared inside of this sine function. There's a nested x squared inside of that cosine function. So as we're working through, like I said, it's really good to have ourselves totally organized so we can combine everything up. So let's write all this stuff. So u, our original function u, is sine of x squared. Now notice that this is different from sine squared. That's actually why they put the squared in here, so that you don't confuse it with this function. And then v is the cosine of x squared. Okay, so those are our original functions. Now to take the derivatives, we need the chain rule. So u prime, we have the derivative rule. So the derivative of sine is cosine. Leave the x squared right where it is. Nothing ever happens to that x squared. And then times the correction factor, which is the derivative of the nested function. The nested function is an x squared. We know the derivative of x squared is a 2x. So that's the derivative of the first function. Next, v prime. Start with the derivative rule. The derivative of cosine is negative sine. And we leave the x squared exactly where it is. Then times the correction factor, which is the derivative of the nested function. The nested function is an x squared. The derivative of x squared is 2x. So we've got everything set up here. There's no need to simplify this stuff right now because we're just going to combine it into a product rule anyways, and our last step will be to simplify. So y prime, for the product rule we do the first times the derivative of the second. So sine of x squared times the negative sine of x squared times 2x. So this really what we're doing is we're crisscrossing here. We're multiplying these two together. And then plus, remember the product rule has plus, quotient has minus. The second times the derivative of the first. And then we're crisscrossing here. So the second function is the cosine of x squared. And then times the derivative of u, so cosine of x squared times 2x. So let's clean everything up here. So first of all, we've got a 2x here, a 2x here. We could factor a 2x out. So y prime is, we're factoring out a 2x, and then in parentheses, we have sine times sine. Because the input function is the same, we can write it as sine squared. So this is negative sine squared of x squared. And then plus, again here, I can do cosine squared. This is cosine squared of x squared. All right, so that is your beautiful derivative. Product rule with a chain rule. Okay, next one. Chain rule within a chain rule. So this is when it would be a good idea to kind of start writing out some of our pieces. So secant is f, that's the main function. And then the square root of t squared minus 9 is g. But if you look closely at that nested function, it has a nested function. All right, so let's keep track of some of this stuff over here. So g, let's write down our nested function here. Our function g is the square root of t squared minus 9. As part of this derivative, we're going to have to get the correction factor, which is the derivative of this function right here. So let's start writing down my derivative, and then we'll come back over here when I need to show some work. So y prime, I start with the derivative rule. So the derivative of secant is secant tangent. So as I'm doing secant tangent, I leave my nested function in place. So secant, tangent, leave my nested function in place, then times the derivative of this, the derivative of the nested function, which requires another chain rule. So let me write this first of all as t squared minus 9 to the 1/2 power. Writing it as a power rule is going to make things a little bit simpler. So now within this function, as I'm trying to find g prime, what I do is I do the derivative rule. So the derivative rule says the 1/2 comes out front, power drops down to a negative 1/2, and then I multiply by the correction factor, which is the derivative of the nested function. It's like a double nested function. The derivative of t squared minus 9 is a 2t. Okay, so now we write down this down here. So let me recap where we are. So the outside is secant, so I start with the derivative rule. The derivative of secant is secant tangent. I left my nested function right where it was, and then I want to multiply by the correction factor, which is the derivative of my nested function. So I worked on that over here, so let me copy it down now. So times 1/2 t squared minus 9 to the negative 1/2, and then times 2t. So let's simplify this up just a touch. So 1/2 times 2 is going to cancel, because that just gives me 1. So now let's write anything algebraic, like this stuff, should always precede anything trigonometric or exponential or anything else. So t, I'm going to put it over the square root of t squared minus 9, just to clean this up a little bit. That's what the negative 1/2 power means. It goes in the denominator, and it's under a square root. And then times the secant tangent. Okay, so this is as gross, I guess, as it looks. This is about as clean as you can get this. So the worse off the original function, the more complicated your denominator is going to be. So we've got that chain rule within a chain rule there. Okay, so let's flip over. Here is where things get even more fun because, chain rule within a chain rule within a chain rule. So we've got a nested function that has its own nested function that has its own nested function. So let's figure out exactly how we're going to handle this. So first of all, the original function, I want us to write this as like this big square root. We're going to put this stuff on the inside all to the 1/2 power. Like I said, that's going to make things a lot easier when we're working on the power rule. So when I work on this, my original g, my inside function, my outside function is something to the 1/2. My inside function, g, is the stuff inside the parentheses. 1 plus the square root of 1 plus the square root of x. All right, so now when I try to take the derivative of that, first of all, let me simplify some things up. So 1 plus, let's write this as 1 plus the square root of x in parentheses raised to the 1/2 power. Okay, so now when I try to find the derivative of g, let's see what's going to happen here. When I try to find the derivative of g prime equals, the derivative of 1 is just 0. When I go to take the derivative of this, I start with my derivative rule. The 1/2 comes out front. This secondary nested function stays right in place. Power drops down to a negative 1/2, and then I have to multiply by the derivative of my nested function, which I don't know yet. Okay, so something else is going to go there. So now let's take this nested function and give it another label, maybe an h. So h is 1 plus the square root of x, aka 1 plus x to the 1/2. All right, so finally I'm going to be able to take the derivative of this because it doesn't have anything nested. So h prime is the derivative of 1, which is 0, and then the derivative of x to the 1/2. The 1/2 comes out front, and the power drops down to a negative 1/2. So back up here to g. When I tried to take the derivative of this function right here, the derivative of 1 was 0. I start with the derivative rule here where the 1/2 comes out front, power drops down to a negative 1/2. Then I'm supposed to multiply by the correction factor, which is the derivative of this expression right here. And that's what I just found here. So times 1/2 x to the negative 1/2. All right, so now over here to the original. So start with y prime. Y prime, I'm taking the derivative of this thing right here. I start with the derivative rule, so I take the 1/2, bring it out front. leave the nested function perfectly exactly where it is, drop the power down to a -1/2, and then I multiply by the derivative of my nested function, which is this beauty right here. All right, so then times 1/2 times 1 plus root x to the -1/2, and then times 1/2 x to the -1/2. All right, so all of this right here, let's do a little bit of cleanup. So 1/2 times 1/2 times 1/2. That means I can put a 1/8 out front. And then I have 1 plus this nice square root right here to the -1/2 power, and then times this thing, 1 plus the square root of x to the -1/2 power, and then times just the x to the -1/2 power. So all of those things are being raised to the -1/2 power. So what I can do, let me take a couple more steps here. So 1/8 times, now -1/2 means we put it in the denominator under a square root. Times, same thing with the next one, in the denominator under a square root. And this one's easy, just 1 over the square root of x. So finally, if I combine these all, multiply across the numerators, and the only numerator I get is a 1 over, multiply all these things out. Is everybody having fun? 8 times the square root of 1 plus the square root of 1 plus the square root of x times this next one, square root of 1 plus the square root of x times the square root of x. And that, oh, that is nice. That is nice. All right, beautiful, beautiful final answer. No need to go any farther than that. Okay, example 11. This notation, this is the Leibniz notation. Remember the d squared over dx squared? All that notation means is that you're taking the second derivative. You don't have to do anything with the x squared, anything like that. This is just the notation for the second derivative. So of course we start with the first derivative. So the first derivative of x squared plus 9 to the 5th. We're going to do the chain rule. All right, so when we're doing the chain rule, we start with the derivative rule. The derivative rule says the 5 comes out front, power drops down to 4. And then I multiply by the correction factor, which is the derivative of my nested function. The derivative of this polynomial is a 2x. So I simplify this up. So 5 times 2x, I get a 10x out front, and then times x squared plus 9 to the 4th. So that is my first derivative. I want to take the derivative of that. So it's going to be the second derivative. So now I'm taking the derivative of this. Should probably be brackets. Okay, so now you may notice, because we haven't had enough fun yet, that this is going to be a product rule. 10x times x squared plus 9 to the 4th. So we get yet another chain rule inside of a product rule. Super fun. Such a great time. So here's our first function. This is u. This is v. So let's make some side notes over here, because remember, like I said, things are starting to get complicated. We want to take some notes here. Okay, so let's get our derivatives. So u is just it's a nice linear function. The derivative of 10x is just 10, the slope. For v prime, we are required to do a chain rule. So very similar to what we just did up here. Start with the derivative rule. Power rule says the 4 comes out front. Power drops down to a 3. And then we multiply by the derivative of the nested function. That's called the correction factor. That is a 2x. All right, so let's combine that up. So again, down here, here's what we've got. First times the derivative of the second. So 10x times 4 times x squared plus 9 to the 3rd times 2x plus the second times the derivative of the first. So just a nice 10 times x squared plus 9 to the 4th. Okay, so let's clean all this up. Equals, so I have a 10x times 4, that's 40x, times 2x, that is an 80x squared, times x squared plus 9 to the 3rd. and then plus just 10 times x squared plus 9 to the fourth. Now while we're cleaning up, this is one term, technically, this is one term. We can take out a GCF. They both have a 10, so we're going to take out a GCF of 10, and they also both have 3 copies of this term right here. So then we're going to take out 3 copies of x squared plus 9, and then let's see what we've got left over. So this term on the left, when I take out a 10 and a copy of x squared plus 9, 3 copies of x squared plus 9, what I have left is an 8x. It's an 8x squared. And then here, when I take out a 10 and 3 copies of x squared plus 9, all I have left to add is an x squared plus 9. So one more time, just a teeny little simplification, because hopefully you can see inside the parentheses we've got like terms that we can combine. So combine up the x squareds, I get a 9x squared plus 9. If you're feeling like doing any more simplifying, you could always factor out a 9, throw that out front with a 10, but I'd say we're probably good right here. All right, so we've got 2 AP problems to run through really quick. We've got a free response problem as well as a multiple choice problem. So this, the AP test loves. They love to do just generic functions, just an f of x, just a g of x, where you don't know what the function is and you don't need to know what the function is in order to make this work. So here's the derivative. They want us to find the second derivative at 3. So start by finding the second derivative, because we're not allowed to plug in the 3 until we're done with that. So the second derivative, f double prime, we've got, again, a chain rule mixed with a product rule. So this is going to be u, and this is v. So over to the right, let's put some steps here. Okay, so again, we're talking just generic f of x. We don't know what it is. We don't need to. U prime, the derivative of x is just 1. It's linear. It's nice and easy. V prime, this is technically like an f of x raised to the 1/2 power. So my main function is something raised to the 1/2 power. My nested function is that mystery function f of x. So I start with my derivative rule. The 1/2 comes out front, and then my power drops down to a negative 1/2. And then I multiply by the derivative of the nested function, the correction factor. But because I don't know what f of x is, which is fine, I just write f prime to represent the derivative. So let's plug everything in. So plug this stuff in. Product rule, I start with, oops, let me write it down here. I start with x times this beauty right here. All of that fun. And then plus v times u prime. So 1 times the square root of f of x. So hopefully we're all okay so far. This is just the generic version of my second derivative. They specifically asked for the second derivative when x is 3. So if we want the derivative, second derivative when x is 3, every single time I see an x, I replace it with a 3. Okay, so lots to work with here. So we have, first of all, this to deal with. We've got this to deal with. They give us this value right here, that f of 3 is 25. So we can simplify everything up. So we've got 3 times 1/2, so that's just going to be 3 halves. And then f of 3 they give us right here is 25. It's the negative 1/2. And then times f prime of 3. Well, they didn't directly give us f prime of 3, but they gave us this function, so we can plug it in there. So times 3 times the square root of f of 3, which is 25, and then plus the square root of f of 3 again, 25. So we simplify all this stuff up. So 3 halves times 25 to the negative 1/2. That's the reciprocal of the square root of 25. So that's 1/5. 3 times the square root of 25, that ends up being 15. And then plus the square root of 25 is 5. Lots of beautiful things happening here. The 1/5 times 15 leaves me with 3. 3 halves times 3 is 9 halves. 9 halves plus 5, just about there, I believe, gives me a 19 halves, or 9.5, whichever way you prefer. Okay, so that one, beautiful, wonderful things happening. Last, what is the slope of the line tangent to the graph of this point, I'm sorry, of this equation at this point? This is going to be a quotient rule. A quotient rule inside of, or with a chain rule inside. So high is e to the negative x. Low is just a nice x plus 1. D high, I start with my derivative rule, so e to the negative x, and then times the derivative of my nested function. The derivative of negative x is a negative 1, so we'll just make that negative. And then d low, the derivative of x plus 1, again it's linear, so it's just a nice neat 1. So combine up using the quotient rule. So y prime, we've got low d high, so x plus 1 times negative e to the negative x, don't forget about that negative, it's the correction factor, minus high d low, so just 1 times e to the negative x, no need to write the 1, all over low low, that's x plus 1 quantity squared. Now keep in mind, when they ask you for the slope at a specific point, there's no need to clean it up beyond this point because you're just plugging in the 1 anyways. So let's plug in the 1. So x plus 1 becomes 1 plus 1, and then negative e to the negative first, minus e to the negative first, all of that over 1 plus 1 squared. 2 squared comes out to be 4. So continue to clean up. This is just going to be some kind of gross algebra. So this is 2, and then times negative e to the negative first. So negative 2 e to the negative first minus e to the negative first over 4. Let's jump down here. These are technically the exact same. I have 2 of them, e to the negative first. So negative 2 and a negative 1 gives me a negative 3 e to the negative first over 4. Finally, to match one of these, let's take the e to the negative first and flip it. So I have a negative 3 up top, and my e flips down to the denominator. So that matches B. All right, so lots of fun things happening here. This is something that you could absolutely see on the AP test, just some of those nasty derivatives that you just have to work your way through. This is why I was telling you to keep yourself organized when you're doing the product and quotient rule.